Record. In the previous several weeks, we learned about triangle congruency. To be able to qualify for congruency, we need 4 theorems, okay? Annie, can you repeat those 4 theorems to prove 2 triangles to be congruent?
S.
Side, side, side. Next one.
SAS. SSA.
Remember, we said SSA is not valid, okay? Remember?
Oh, yeah.
We have this triangle. This guy.
So ASA.
Thank you. The last one is? S, correct?
S.
So, yeah. So as long as you have side, 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 or side angle side, but here, this angle has to be between these 2 sides. If we say SSA, that one is not working, okay? Next one is ASA. The last one is AAS. So did we see, if you want to prove 2 triangles are exactly identical, which is congruent, you have to have at least one side equal. You see here? This one, you see this one side equal. This one, you see one side. This one, you see 2 sides. This one, you see 3 sides. So from today, we learned the triangle similarity. The similarity will be different. Look, these 2 triangles. And look at here. These 2 angles are congruent. These 2 angles are congruent. But this side does not equal to this side. And this side does not equal to this side. For these 2 triangles, we call them similar triangle, okay? So as long as we know you have 2 angles correspondingly equal, because triangle interior angle summation is 180 degree. If the interior angle summation is 180 degree, and then the third one will also be equal, because this plus this plus this equals 180. This plus this plus this is 180. And this 2 pieces equal. So that guy has to be congruent to that guy. But they didn't tell you if the side equal. Then you will see these 2 triangles are similar triangle, okay? This is called AA. As long as you know 2 angles correspondingly equal, you can tell these 2 are similar. That's called AA. The next one, Alan. I want you to go ahead, read this theorem, please.
SSS similarity theorem. 2 triangles are similar if all corresponding sides are proportional.
As we can see, this triangle and this triangle, if we list those ratios, if those ratios are proportional, okay, and you see 10 divided by 5 equals 8 divided by 4 equals 6 divided by 3. If this is correct, then these 2 triangles are called similar triangle also. You can prove this to be true. You can see this is similar. But you cannot list this equation in the wrong way. If you do 10, for example, over 4, this guy will not equal 6 over 5, will not equal 8 over 3. So when you list this equation, you have to be careful. You pick the biggest one over the biggest one, and you pick the smallest one over the smallest one, and you pick the middle one over the middle one, okay? So when you list the equation, you have to watch out those numbers. When you list them, you have to put them in the correct position to check if it's proportional. Okay, that's the second one, SSS. And the next one is SAS. I want Albert. Would you please read this one, please? Go ahead.
SAS similarity theorem. Side angle side SAS similarity theorem. Two triangles are similar if both of the following are true. Two sides in one triangle are proportional to two sides in another triangle. The included angle in the first triangle is congruent to the included angle in the second.
Okay, so in these two triangles, you can write down this equation. 6, you choose the short one over the short one, the longer one over the longer one. If this equation is true, and at the same time, the angle between them are also equal, then you say these two triangles are similar, okay? But if you were not given this angle equal, you don't know if these two angles equal. You cannot say these two triangles are similar. If you were told this angle equals this angle, you cannot tell this guy is similar either. You have to make sure the angle are between these two sides so that you can qualify this SAS, okay? So the S here doesn't mean congruent. Those S here just means proportional, okay? So you're not going to see this 10 equals this no longer. You'll just do their ratio to check if it's correct. So that's the 3 important theorem. And today we will use, we will start to use those triangle similarity to do something very interesting, okay? First, I want to show a proof, okay? This one is a little bit hard, but I will guide you through this. In this triangle, everybody pay attention here. Angle 1 is congruent to angle 2. So this is an angle bisector. This AD is angle bisector of angle BAC. Okay. If AD is angle bisector, then AB over AC equals to BD over CD. This is called an angle bisector theorem. And we want to prove this one by ourselves. Okay, let's see here. Felix, let's see here. If we were given angle 1 equals angle 2, and we want to prove AB over AC equals to BD over CD, okay? Now, it's not easy to prove this one by just knowing here. So we will draw some lines. The line I'm going to draw is, I draw a line CE parallel to AB, okay? I draw the line CE parallel to AB. Now, Felix, look at here. I'm going to ask you the reasons, okay? So first, I say CE parallel to AB. This is given, so I put given here, okay? And based on ABC parallel, we get angle 1 equals to angle E, okay? So I ask you, Felix, what should I put over here? Can you tell me what should I put over here?
Alternate interior angles theorem.
Very good. So this is alternate. Okay. Okay, very good. And then angle 1 equals to angle E. Angle 1 also equals to angle 2 because this guy is angle bisector. You can see definition of angle bisector, correct?
Yeah.
Next, next, look at here. Angle 1 congruent to angle E. Angle 1 congruent to angle 2. So I'm able to say angle E congruent to angle 2, correct?
Yeah.
By what property?
Transitive property.
Transitive property. Very good. Now, if you know this angle equals this angle, is this guy a isosceles triangle? If you have two angles equal, this triangle will be a isosceles triangle. Okay, that makes sense.
Yeah.
If the two angles equal, you can tell this guy is a isosceles triangle. If this guy is an isosceles triangle, you can also say AC congruent to CE. Okay, that makes sense.
Yeah.
Because as an isosceles triangle, your two sides also equal. So you can tell AC is congruent to CE. So basically, after we prove AC is congruent to CE, as long as we prove AB over CE, see, AC was replaced by CE, equals to BD over CD, okay? AB over CE equals BD over CD. This is a similar triangle. So we proved this two equal, so this guy got replaced by CE. So as long as we can prove this one, then we are able to prove this one, right? By a substitutive property. Make sense?
Yeah.
Okay, so we will focus on how do we prove this part. Okay, this part we will use the similar triangle information to do it. Now I'm going to call the next student, Annie. Let's see this together, okay? Now we focus on to prove this. Let's do this guy. See how we can reach. Look at here. We were given this line parallel to this line. So we will be able to tell which angle equals to which angle. What you want to put here?
Angle 1 is congruent to angle E.
Because
Because they're
alternate interior
alternate
angle.
interior angle.
And then does this two angle equal?
Yes.
Vertical angle. So this angle equals this angle, correct?
Yeah.
In this triangle and in this triangle, these two angle equal. These two angle equal. So you can prove these two triangles are similar because
Because
look,
like,
the theorem we learned today, correct?
yeah.
Two triangles are similar if two angles in one triangle are congruent to two angles in the other. You have this angle equal. You have this angle equal. Then AA will say these two triangles are similar triangle. Make sense? All right. So over here, because this angle equals this angle equals this angle. So these two triangles are similar triangle, okay? Correct. after you prove these two triangles to be similar, we know that for similar triangle, your corresponding part will be proportional. AB over EC, correct? Yes, this part and this part are corresponding part. And then angle 1, opposite side is BD. Angle E, opposite side is CD. So we have AB over EC equals to BD over CD. Does this make sense to you? Okay. We have already proved that CE and AC congruent. So AC, CE congruent, this guy will be replaced by AC. So finally, we can prove AB over AC equals BD over CD. Does this make sense now? Okay. All the students, we have already finished proof this theorem. This is called angle bisector theorem inside a triangle. I ask, is there any questions so far? Alan, do you have any question here?
No.
Everything is clear so far?
Yeah.
Okay. How about Felix and Albert? Is everything here okay?
Yeah.
Yeah.
Okay. Now we are going to do our real practice. Okay. Let's see here. Yeah, we can start from this. Okay. Look, they show you these two guys similar. X, Y, Z. R, Y, S. Okay. Let's figure out those congruent angles, please. Let me call Alan. Can you tell me which angle corresponding to which angle? Go ahead, please. Alan, go ahead.
Angle X and like yeah.
Congruent to what?
R.
Well, this point has several different direction lines. You cannot call R. They don't know if you are talking about this angle or this angle or this angle. So you have to say angle YRS. Does this make sense to you?
Yes.
Okay. Next. Angle Z is congruent to?
Is congruent to angle Y R S Y S R.
Very good. Okay. Last one.
Angle.
Yeah, we can see angle Y, but let's put RYS equals to XYZ. Okay.
Okay.
So we do this big one first. Okay. Yeah. We use this left to corresponding the big triangle. We use the right to corresponding to the small triangle. So we see XYZ is congruent to angle RYS, correct?
Yeah.
Next, we want to write down the proportion. This piece over this piece will equals to who?
RY over YX. Is equal to S RY over xy
xy.
is equal to sy over zy.
Thank you. Equals
Equals xz.
this guy. You see?
Oh, yeah.
RS
rs
over,
over xz.
yes. Okay. Look, when we see this, x is this angle. Inside this triangle, this first letter, R, is corresponding to this angle. This Z is corresponding to this S. Okay? And the Y is corresponding to Y. So when we write down this triangle, similar triangle, we make sure we make those points exactly corresponding correctly, so that when we write down those proportions, we can do a shortcut. The shortcut is this, okay? First, you do this. You do RY is the first two letters. You do XY. Yes? You see? The first
Yeah.
two letters. And then SY is here over YZ, right?
Yeah.
SY over ZY. And then the last one is XZ. It starts from the right, so RS over XZ. Does this make sense now?
Yes.
Yeah, so we can do this very quickly. We can also look at the graph and figure out the proportion, okay?
Okay.
Does this make sense to you?
Yeah.
Okay, next one. Albert, let's do next question. They give us JKLM. So J will be corresponding to Q, okay? That makes sense?
Yeah.
Because this line here, they give you multiple lines from one point. So you cannot call this angle as angle R, but here you just have one angle here. So you don't worry, you just call angle J and angle Q perfectly, okay? So we will write down angle J is congruent to who?
Angle K.
Angle J is corresponding to angle
I mean,
Q,
angle
yes?
Q, yeah.
Okay. Next, angle K is corresponding to who?
Angle R.
Yes. Angle L,
Angle S.
angle S, angle F,
Angle P.
angle P. Very good. Let's figure out those proportions. You have a triangle, you have three things to be equal. You have a quadrilateral, you will have four things equal, okay? Let's go ahead. I want you to use this way, say JK over QR, okay? Let's do that way. So I'm going to write down four fractions. Okay, let's go ahead. So we do JK over who?
QR.
Equals,
KL over RS.
very good, KL over RS. Equals,
LM over SP.
very good, LM over SP. Last one is
JM over QP.
JM over QP, very good. Do you like this way?
Yeah, it's pretty easy.
Yeah, then you will not be dizzy by figuring out which one over which one, okay? Next. Felix. Let's see number 4, okay? This figure are similar. They have a scale factor of 2 over 3. So if this piece is 2, this piece will be 3. But this is not 2, this is not 3. So we will do a proportion. Do you think which equation should I write down? Give it a try, please.
42 divided by 2 is equal to, wait,
We can
Um,
list it 2 over 3 on the right, okay?
2 over 3 is equal to 42 over x.
There you go. And then, how do we do?
We can divide 42 by 2, which is 21.
Okay. And this guy also divided by 2 becomes the 1, right?
Yeah,
So x will be,
will be 63.
there you go. Thank you. Nice. Next one, number 5, Annie. Let's do number 5, please. A scale factor of 6 over 5. Let's go ahead and write down the proportion.
28 over x equal
Equals
6 over 5.
We may have to put this on the top, 28 on the bottom. Does that make sense?
Okay.
Yeah. So we do x over 28 equals to 6 over 5. Does this make sense?
Yeah.
Okay, and we can do cross multiplication, right? Times 6. How much is this?
33. Oh,
Really? I'm correct, yes?
yeah.
Okay, so we do this, okay? Let me show you a quick way of calculating this. If you divide it by a number of 5, you can do this shortcut by times 2 on top and the bottom, okay? And then this guy times 2. Divided by 10. So you can easily figure out this is 33.6, okay?
Yeah.
That makes sense?
Yeah, yeah.
Okay. Next, number 6. Alan. Let's go ahead to number 6, please. Okay. How do you want to list the proportion?
28 over 25.
So that's BC over DE, right?
Yeah.
Okay, hold on. Be careful. Let's write the proportion first by this ratio. Okay. Let's be careful. AB over who?
Over E over FE or over D. Oh yeah.
Okay, equals BC over
PC over DE.
no. You see here, you have these two triangles similar. AB first 2 letters, DE first 2 letters, BC last 2 letters, EF last 2 letters. Okay. Make sense?
Yeah.
Okay. And then we can safely plug in those letters and the numbers. Make sense now?
Yeah.
Now go ahead, plug in the number, please.
6 over 25.
X over 25.
It equals 28 over 20. 28 over 20.
Mhm. When we have this, I would like to do the simplification first, okay? Can we, when we do those calculations, if we can simplify the bottom together, we do it. If we can simplify the right together, we can do it. If we can simplify the left, we can do it. If we can simplify the top together, we can also do it, okay? So 25 and 20. 25 divided by 5 is how much?
5.
This guy divided by 5?
4.
4. Oh, so which is saying x over 5 equals to 7, correct?
Yeah.
So x equals
35.
35. I would like to do the way like this. In this way, I can quickly find out my answers. Because if I don't do the simplifications, I do 20x equals to 28 times 25. If you times this, it's going to be a big number first, and then you divide by this, it's kind of slow, okay? That makes sense?
Yeah.
Yeah, but there is still shortcut when you do 28 times 25. Look, how do you do this multiplication faster? Here is a trick. 25 is same as 100 over 4, correct?
Yeah.
25 is 100 over 4. So 28 over 4 is 7. So in that way, I can figure out this to be 700 quickly, you know?
Yeah.
Yeah, you can do this. You can do this, definitely. You can do this. This is still 700, but I think this way is slower than this way. I prefer to do this faster way. And this is even faster, okay? Makes sense to you? Okay, next one. Albert, let's run number 7, please. Okay, based on those, can you tell me those proportion? Go ahead. SR over who?
SR over ZY.
SR over ZY. This is SR, this is ZY. And then PS over
Is over WZ.
PS WZ. You got it. Very good. WZ. Now we plug in the numbers, please.
SR is X
Okay.
and ZY is 32.
Okay.
And then the next one is 75 over 40.
There you go. Let's do the simplifications before we do the cross multiplication. Okay. 32 and 40. 32 is divisible by who?
Could you say it again? I was lagging.
32 is divisible by 8. Correct.
Yeah.
Divided by 8 will be 4, right?
Mm-hmm.
This guy divided by 8 is how much?
5.
It's 5. So x over 4 equals to 75 over 5 is how much?
What do you mean by how much?
75 divided by 5 equals?
Oh. 15.
Yes. So x equals
15 over 4.
15
I
times
mean,
4.
60.
Okay. Okay. All right. This way is definitely faster than doing 75 times 32, give you a big number and then divided by 40. I don't like this way personally. I like this way faster. Okay. Makes sense to you?
Yeah.
Thank you. Next. Felix. Let's go ahead. Write down the equation for number 8, please. Go ahead.
I think it's
Write down those letters.
HJ,
Let's start with D, E, H, J. Okay.
yeah, 9 over 15.
Let's
Yeah.
write the letters first, and
Okay,
then we plug in.
DE
Okay.
DE over HJ is equal to EF over JG. And then FD over GH.
All right. Very good. Now let's plug in. Go ahead, please.
So D is 9, and then HJ is 15.
D is 9. HJ is 15. EF is 14. And then GG is Y, right?
Yeah,
Okay. FD is 12. GH is X. Correct?
yeah.
Okay. Now we want to simplify 9 over 15. Simplify this, it's going to becomes what?
3 over 5.
3 over 5. And then we can do the cross multiplication. 3y equals
70.
yes. And then this 12y equal, we can do this, okay? Do here. 3x
And 60.
okay? So y equals
Like 23.
70 over 3.
Oh yeah.
X equals,
20.
there you go. Does this make sense?
Yeah.
Okay. All right. Let's see if there's, okay. Now, next, any. Let's go ahead and run number 10, please.
AG over KX
Okay.
equal GM over XD.
Equals
32
oh,
over
yeah, you already finished this. Okay, yeah, so we don't need to list everything.
32 over X plus 3 equals 36 over X plus 6.
Yeah, we might want to try to simplify the top numbers first. 32 and 36, we can change it to who?
8 and 9.
And then we can do the cross multiplication. Go ahead, please.
So 8x plus 48 equals
Mhm.
9x plus 27.
That's it. Very good. So
X equals 21.
very good. There you go. Thank you. Thank you for submit very neat homework every week. Okay. Oh, Ellen, you have question negative. Oh, what Annie did here is this. So first you do 48 minus 27 and then 9x minus 8x. Okay, so which is 21 equals x, so x equals 21. Okay. Ellen, I'm going to ask you to do the next one. Okay, number 11. So far, the question here is not too hard. Okay, later on, we will see those proportions with quadratic equations. Okay, for example, if I give this side with an x, then you will have a quadratic equation because you will have a second order of x. Okay, so which shows algebra 1 is still important foundations for doing geometry. Okay, go ahead to this one, please. Write down the proportion first. Go ahead.
TL over CH equals LY over HK.
TL over CH equals to LY over KH, correct?
Or yeah,
Okay, let's go ahead.
25 over 10 equals 4x minus 1 over x plus 5.
Okay, there you go. Can we simplify here?
Yeah. By 5.
Okay, let's do the cross multiplication.
5x plus 25 equals 8x minus 2.
There you go. Next,
X equals 9.
so you have 3x here, 29 here, so you have x. Oh, sorry, I have a typo.
27.
Okay. There you go. Very good number sense. That's good. Yeah, let me see if, okay, hold on. The question here, let's see. All right, let me see if there's some harder questions. Most questions are very similar. Let me call student for the next one, okay? Albert, let's take a look at question 7, please. What proportion you want to list first?
JL is equal to NP.
So JL over
NP
equals
JK over NM.
okay. Continue.
And that would be NX plus 1 over X plus 5.
So JL is 9x plus 1 over
X plus 5.
x plus 5 equals
49 over 14.
okay. Tell me what way you want to simplify this. Okay, yeah, we can do this, but before we do this, we would like to simplify this a little bit. Okay, go ahead.
49 divided by 7 and 14 divided by 7.
So 49 over 7 is who?
Huh?
14, you want to simplify this. You want to change this to a simple number, okay?
Yeah, I want to divide it by 7.
49 over 7 is 7, right?
Yeah,
14 over 7 is
2.
2. Now, can you please do the cross multiplication? Go ahead.
18x plus 1 over
Oh, you mean put, no, 18x plus,
plus 2
yes, 18x plus 2 equals,
7x plus 35.
there you go. Next step.
9x,
Mhm,
11x
thank you.
equals
Equals,
33.
thank
X
you.
equals 3.
X equals to 3. Okay. All right. Next one. Felix. Number 9, please.
XY over RS
XY
is
over RS. Mhm.
is equal to YZ over ST.
YZ over ST equals
ZX over TR.
the X over TR. Now let's plug in the numbers. Go ahead.
XY is 5x minus 3.
Okay.
And
Over.
then RS is 3x over 3x plus 2.
Equals.
Well, we don't know what YZ is.
Yeah, this thing we
And
can skip. We can just jump to here.
ZX is 60 and TR is 40.
Yeah, we don't want to do this big number. We want to do something simplify here. Okay. How do you want to do that?
60 over 40 is 3 over 2.
Both divided by 20. So this is 3 over 2. Continue. Cross multiplication.
Yeah. So it would be 10x minus 6 equals 9x plus 6.
There you go. So
We add 6 to both sides and then minus 9x, and then x would be 12.
very good. Okay. That's nice. Next one. Annie. Let's go ahead to number 10, please.
BC
BC over
BC over DC
yes equals
AC over EC.
Yeah, let's go ahead, plug in.
3x minus 5 over 32.
Okay. Equals
5x minus y.
minus 5
Oh,
over
Yeah, over 56.
over 66. Okay. So this is thing I would like to make sure everybody truly understand. Okay. This is proportion. A over B equals C over D. If A and B can be simplified, then you go ahead and simplify here. If C and D can be simplified, then you go ahead and simplify here. If B and D can be simplified, you can go ahead and simplify here. Last one, if these two on the top can be simplified, you can go ahead and simplify there. But please don't get this mistake by doing simplification from here to here. That's wrong because A times D equals to B times C. If you do the simplification between these two numbers, you will have trouble. If you do the simplification between these two numbers, you will have trouble. You can only do the simplification on the same side, either on the left or on the right or on the top or on the bottom. Does this make sense? Okay, now tell me what you want to do the simplification here.
32 and 56.
So this guy, you change this to
4,
this guy.
7,
Very good. And then let's go to the cross multiplication.
21x minus 35 equals 20x minus 20.
Okay.
And that equals x equals 15.
X equals 15. Okay, very good. Yes, we are going to jump to some a little bit harder question. Ellen, question 13. Let's take a look. We want to be very careful here. Look, this piece over this whole thing equals to this piece over this whole thing. Okay? So, so let's first write down the letters. Okay? We do, we do SQ. Oh, sorry. We do SQ. We have SQ over who?
PQ
Very good. PQ equals
QT over
yeah, that's fine, but we will not use it. Okay, yeah, we can just jump to ST.
ST over PR.
Very good. Now we can plug in. Okay.
Okay.
Go ahead.
For the second one, is it PR or PQ?
PQ. We do SQ is 8. We can plug in SQ as 8. If this is 8, and this is X plus 5. So PQ should be?
PQ should be X 8 parentheses X plus 5.
So you mean this plus together, right?
Okay.
This piece is X plus 5. This piece is 8. So this total is X plus 13. Does this make sense to you?
Yes.
So 8 over X plus 13, correct?
Yeah.
Equals X
minus 9
over
21.
There you go.
For the letters, you put PQ on the second one.
Oh, sorry. My
Yeah.
bad. I have a typo there. It's PR. Thanks for correcting me. Okay.
Yeah.
All right. Now,
Okay.
This is the time for checking our quadratic foundations. Go ahead, please.
For the 8, you can simplify that with the 4 to get 2.
You want to simplify this with who?
Oh, okay.
No, there is
Actually,
nothing.
okay. So 168 equals
Let's first do this, okay?
like x squared minus 9x plus 13x minus 97. Oh, 97.
Sorry.
Equals 160.
Hold on. I don't think it's correct. I don't think so. 13 times 9
Oh,
is
sorry.
117.
Yeah. Okay. Yeah.
Equals
168.
yes.
Okay.
Okay. So x squared plus
4 minus 117
4x
equals
minus
minus 117 equals 168.
this equals how much?
It equals negative negative 200. No, negative 300.
Hmm?
Oh no, 200. Oh,
Am I correct?
yeah.
Equals 0, correct?
Yeah.
Okay.
Then you can
So we
factor.
do the we want to factor. So did you
Yeah.
know this way? I don't know if your school teacher teach you or not. We do
Yeah.
those cross multiplication. Yes.
Yeah.
Let's see 285. 285 equals to 5 times who?
5 times 57.
Okay, 57.
But it can't
57.
work.
57 is 3 times who?
5 times 57 is 3 times 9.
19,
Oh, sorry,
right?
sorry. Yeah, 19.
19. Okay.
Yeah.
So up to here, you put 19 here, you put 15 here. Look, I don't know if your school teacher teach this. All my students who learn algebra 1 with me, all of them know this skill. Number 1, 1 times 1 is equals to 1. Number 2, this 2 product equals this, but you also have to make this guy happy. So you want to make this to be negative. You can put negative here, but if you put negative here, yes, your product is negative, but this gives you negative 19 plus 15, which is negative 4. Negative 4 does not corresponding to this positive 4. That's why I switch this guy over here. Does this make sense to you?
Yeah.
Okay. So, so this becomes this
19,
is x plus
x plus 19
times
x minus 15 equals 0, and
there you go.
2 are negative 19 and 15.
Look, this is geometry question. You won't be able to have a negative, so you will cross out this solution. Make sense? Yeah, we will cross out this one. So we only keep x equals to 15. Okay? Does this make sense now?
Yeah.
Okay. All right. So here, this one, this give you a list of all these 3 theorems we have learned today. Okay. Yeah. Today's topic actually is not hard. Yeah, I changed this rotation. Yeah, this page is better. Today's topic is not hard. As long as you know the AA and SAS, SSS and SAS, you can do it. The only difficult part for this class this week is when those quadratic things come back, okay? If we see this kind of thing, we need to show our foundation good enough to solve this kind of quadratic equations. And I do need everybody to be able to do those factorings, okay? If anyone have trouble to get this to this step correctly, let me know. I will send you a link for one of my videos for doing those factorings. You have to make your factoring skills pretty well for doing this part, okay? And I believe all of you will take PSCT in October this year, okay? So that these are all important foundations to make you get a good grade for that test, which is important for your college applications. As for today's class, next week, class will become harder, okay? I just give you an early warning. Next week, we will focus on doing proofs. You see many different lines for doing those proofs. So everybody, please be ready for next week class. You need to finish all the homework for this week to make you ready for the next week class, okay? That's for today's class. I will upload the homework and I see you next week. I will also upload the videos. All right, thank you. See you next week. Bye-bye.
Bye, thank you.
You're welcome.